In this example, I want to use multi-regression to solve a particular problem of interest. Let's go ahead and look at the problem. We have the Times Observer is a daily newspaper in Metro City. Like many city newspapers, the Times Observer is suffering through difficult financial times. The circulation manager is studying other papers similar cities in the United States and Canada. She is particularly interested in what variables relate to the number of subscriptions to the paper. She is able to obtain the following information on 25 newspapers in similar cities. The following notations are used. Sub is abbreviated form of number of subscriptions in terms of thousands. Population, the metropolitan population, in thousands. Advertising budget is abbreviated to ADV. It's also in terms of hundreds of dollars. And finally, the income, the median family income in the metropolitan areas where the data is collected in terms of thousands of dollars. So for this particular analysis, we're going to use multi-regression analysis. We first need to determine the regression equation. We need to then conduct a global test of the hypothesis to determine whether any of the coefficients are not equal to zero, meaning is there anything significant about the regression analysis, and then finally conduct the test on the individual coefficients. Would you consider deleting any of them? Now, in a situation where we delete them, it's a situation where there are some insignificant factors in the regression analysis, and we remove insignificant factors because as we move the factors, essentially those factors are producing noise, and we want to eliminate that noise, aka variation, from the model. So let's go ahead and open up that starting file. Okay, so once we open up the starting file, what we're seeing here is a list of the information that we've collected. Subscriptions, total population, advertising, and the income. One of the first things we're going to have to do is identify what is the dependent variable attribute amongst these variables collected, and what are the independent. What is independent to income? Well, in this particular case, we have several. We have X1, X2, and X3. Income will be our dependent event. So we have subscriptions that are going to affect the income. We have populations that's going to affect the income, and advertising dollars is going to affect the income. So we would say that all of these are independent attributes where income is our dependent. Okay, so let's determine the regression equation first. And I'm going to provide some space here for this, and as well as some formatting. Okay, so what we have here is an extension of just regression analysis. In regression analysis, we have y equals a plus b times x, in other words. Well, here what we actually have is a set of three x's. So actually we have b1 times x1. We also have b2 times x2 plus b3 times x3. And that's it. We only have three independent attributes, so we only have to go as far out to x equal 3. Now, if you were to extend this to multiple x values, I just want to write the general form of this equation for your own benefit. Plus ... all the way to bn xn. So if we had 100, it would go from 1 all the way to n of 100 in this series. Okay, so that's the general form. What does our situation look like? Our situation looks like this. We're trying to predict income is equal to the intercept plus the subscriptions, and it's going to be the subscription coefficient, times the subscription plus the population, I'll just say pop coefficient, times the population plus advertising coefficient times the advertisement, a DV, I guess I've got this backwards here, a DV times the advertising dollars. So that is our general expression here that we're going to follow. So the first thing we need to do after we have identified the equation, we need to run our analysis. Let's go to data analysis, find regression, hit OK. Our input range, actually I would prefer if it said output, because that's going to be the output of our model, but that's beside the point. Our input Y range is going to be equal to the range of all of our Y inputs. The range X will actually be equal to the 3 columns of X values. And I must point out that these have to be contiguous cells. They have to be adjacent columns. I couldn't do something like this. Let's say, hypothetically speaking, X2 becomes statistically insignificant. I couldn't highlight X1 and say the next parameter is X3, leaving X2 out of the analysis. They have to be adjacent. So I'd have to move this range of data elsewhere, somewhere else on the spreadsheet, in order to get X1 and X3 together so they can hypothetically be used as the only attributes. So that is a little bit off topic right now, but it'll come into play later. So X range again is subscriptions, advertisement, all the way down. We do in fact have labels. Our output range is going to be here, and we have our analysis, the results of our study. Let's take a look at it. Looks like the R-squared value is roughly 60%. That means based on our regression analysis, implementing this particular equation, roughly we explain 60% of the variation in the income attribute. Okay, first we need to conduct the global test. And our global test is going to test whether there's any significant factor in our analysis, any of the intercept, subscription, population, advertisement coefficients. So in this regard, we have a F stat and an F critical, and our statistic, our test statistic, is way to the right of F critical. So it means that we have at least one attribute out of the 3 independent and the addition of the intercept. At least one of those is statistically significant. So why don't we document this down here? We have H0 and H1, and we're going to document the hypothesis for the global test, not text, but test. And I'm going to place that analysis or those statements here. The H0 is going to be that there are no significant factors or coefficients. The H1 is that at least one attribute, one factor is significant. Okay, let's apply some general formatting here, and that's probably good enough. Okay, so we have our initial hypothesis statement. So since we can conclude that at least one is significant, we might as well investigate this further and look at the very next table. Now in this particular table, we're going to have 4 hypothesis tests. I'm going to paste the formats of this table 4 times. And I can go ahead and copy the H1, H0 statements. But we have our first, let's go ahead and put everything in the center. What we have here is a hypothesis for the intercept. Down here we'll have the hypothesis of the subscription coefficient. We'll next have the hypothesis of the population coefficient, and finally we'll have the hypothesis of the advertising. Okay, so in this case for the intercept, we are going to write out the initial hypothesis that the intercept equals 0. Basically, intercept does not equal 0, meaning it's significant. Subscription is the same thing. Subscription is 0 if it is insignificant, and subscription does not equal 0 if it is significant. Same here, population is equal to 0, meaning the coefficient. Population coefficient is not 0. And finally, the advertising coefficient is equal to 0 or not. Okay, so now we just need to make conclusions. The easiest way that I know to do this is just to highlight these, change it into percentages, and quickly compare the p-values with the alpha values. I would say here, for the intercept, we can conclude that it is statistically significant because it's a p-value of 0. For subscriptions, it's also a p-value of 0 or very, very close. Population is very close to p-value, or the alpha value I should say, but it is actually greater. So here I would conclude that the population coefficient is statistically 0. And again, one way to determine that is looking at the 95% confidence interval. We actually have a sign change, a negative all the way to a positive. So it means 0 is in the somewhere between that range. So statistically, I can claim that population is 0. Finally, same situation here. We have advertising dollars spent is a p-value of 32, so it is really insignificant. So let's go ahead and document that. Advertising dollars is 0. Now, if I had to identify which factors I would remove from this study, I would remove my overall conclusion. I'll call this, let's call this first iteration conclusion. My first iteration conclusion is that I would consider moving 2 attributes. So consider removing 2 attributes, which would be population and advertising. Okay, so why is this the case? And this is going a little bit further in the analysis, and I'll just provide some extra spacing here for text. Why is this the case? Well, if we remove these insignificant factors, what we will find is that we can generate a better model. Now, right now, the R-squared is 59, and the standard error is 0.20. Let's just demonstrate this concept by rerunning the analysis and removing the insignificant factors. So a little bit beyond the scope of what the problem is about, but this is a very important part. I'm going to remove both population and advertising values, and there's a couple different techniques that we can use. One is called Stepwise. Stepwise would remove the least significant attribute first. So I'm going to remove advertising first. And if we're going to implement this stepwise strategy, I'm going to stick with my first iteration conclusion, but I'm going to consider removing 1 removing the least insignificant, no, I'm sorry, yes, insignificant attribute, which would be advertising. Okay, let's just go ahead and run that. So we have data analysis, regression. Everything stays the same except for the location of the report, which I want to put below here, and the set of X's. I'm going to use both subscription and population and not use X3. Let's go ahead and hit OK. This is the second generation. We have one less attribute. We are still significant. At least one attribute explains the variation in the Y attribute. We can quickly look at P. And now we have two significant attributes and one insignificant. Now it turned out to be that during the first iteration, the p-value was 5.3%. It had a chance to go below 5, which is why I wanted to use this stepwise fashion of removal. But instead of going down, the p-value and value, it actually went up. So my second iteration conclusion is that I would consider moving the least significant attribute, which would be population. Let's run it again. Data, analysis, regression. Let's change the X to just subscription now, and remove the report down here. And now let's look at our results. So now we have our p-values that are both 0, which means the model has reduced in form to just y equals a plus subscription coefficient times subscription. And it's because all those other attributes were noisy. So this is a very laborious process, but one in which is very powerful because we result with the best equation that we essentially could derive from this data. Now I just want to make a final remark that since we went above the scope, if you are asked to do this type of analysis where you are removing attributes and solving the problem again, for example, you will be explicitly told to do so. And you could be asked to remove the least insignificant attributes, or you could say, we could tell you to remove all insignificant attributes all at once. So those are the two differences.